Hello, this is Farhan Shakil from the Republic 2.0, and here I'm back with the guest paper for 2025 8 PH Excel Physics. And in this guest paper, I'm just going to solve the May 23 paper. I've already posted the part 1 of this video having all the multiple choices. Now I'm just going to start with the structural problems, and here we go with the question number 9. In the question number 9, the examiner says that a student connects the circuit shown. The battery has negligible internal resistance. You've got 6 volt, 10 volt is the constant resistance, and there is a voltmeter around it, and then you have got a variable resistor. And then a student increases that resistance of the variable resistor from 0 ohms to 40 ohms. Determine the range on the readings of the voltmeter. So we just need to determine the range of the readings of the voltmeter. So what we're going to do first, when the resistance of the variable resistor at 0 ohm resistance, if the resistance of the variable resistor is 0 ohms, what does that mean? The voltmeter would show the whole of the total read, whole of the voltage. The total voltage is 6, so it is going to show 6 volts. But when this is going to be the maximum resistance, meaning thereby 40, we need to determine the voltage across it. So by using at 40 ohms resistance, I'm just going to use the equation for the potential divider. The total voltage is 6, right? The total voltage is 6 divided by the sum of these voltages, and that's going to be 50, is equals to, now I'm just going to talk about this voltage across 40. I'm going to keep it like V divided by the total voltage across it right now is something like, uh, you know, across this one, across the voltmeter has to be 10, right? And now from this equation, V should be equal to 6 upon 50 times 10. And that gives me approximately 5, 1, and 6 upon 5 is 1.2 volt. So the maximum reading on the voltmeter that we can have is 6 volt. And the maximum reading on the minimum reading on the voltmeter could be 1.2 volts. Now we'll get to the question number 10. And the question number 10 says that a model rocket accelerates vertically upwards, then decelerates due to gravity until it reaches the maximum height. The VT graph of the rocket until it reaches the maximum height is shown something like this. Show that the rocket reaches a maximum height of about 68 meters. So if you want to calculate the maximum height, that is a total distance covered by the rocket in the upward direction. And how you can get the distance from the VT graph by just calculating the area under the graph. You can see that this is some sort of a triangle. And if you want to calculate the total distance covered by the rocket or the maximum height gained by the rocket, you just need to use the formula half times base times height. Plus now we can see that the base is approximately, if you kind of measure it down, the base is approximately 4.5. So you've got 4.5 times the height of the rocket is something like 30. And when you're going to solve it down, 2 times 15, 15 times 4.5 has to be something like 67.5 meters. So you can see that the total height covered by the rocket is approximately, what it was, 68 meters. Now we'll get to the next question. And when the rocket reaches the maximum height of 68 meters, the parachute opens, and almost instantly the rocket reaches a terminal velocity of 2 meters per second. Because it is moving down, so its terminal velocity has to be negative 2 meters per second, right? Because it went to the maximum height, now it is coming back, so its velocity should be in a direction or a sign opposite to the original one. So you can see that right after 4.5 seconds, the parachute opens, and now a straight line would take you to the -2, and this would be -2. So this is the velocity. And everybody knows that terminal velocity has to be uniform, right? Terminal velocity has to be uniform. And if the terminal velocity is uniform, the body would keep on moving with a -2 meters per second square velocity. But we never know for how much time it would keep on moving. So, initially, first of all, if you think about it, we need to calculate the time of the descent. And the time of the descent can easily be calculated by just using t is equals to, since v is equals to d upon t, so t is equals to d upon v. The distance we just calculated was 67.5. The speed is 2. If you're just going to divide them up, you'll have 33.8. That is the total time of descent. And, it has to move, uh, cover up the height in 4.5 seconds as well. You can see that over here. So, the total time it's gonna take would be 38.5, not 33.5 plus 5 and plus 4.5, sorry. And that's gonna be 38.3. So the body would keep on moving with the negative 2 meters per second square velocity until we get to negative 38.3. And that should be something like over here, right? So that is the shape of the graph and the parachute opens up and the body starts moving with the terminal velocity. In the C part, the rocket is fired upward a second time when the wind is blowing. The rocket falls with a vertical velocity of 2 meters per second. So it is falling with a vertical velocity of 2 meters per second and a horizontal velocity of 1.5 meters per second. Determine the velocity of the rocket by drawing a scaled diagram. So first of all, we've got 2 meters per second, and I'm supposing that, uh, you know, two boxes would give you, or we can say, two boxes represent, yeah, one big box represent 0.5 meters per second, right? So I'm just going to draw a curve, and that curve would look like, since the body is moving downward with a velocity of 2, so 1, 2, 3, and then it's going to be 4. So that is the downward velocity, which it would be 2 meters per second. And then after this thing, you've got 1.5 meters per second. So 1.5 would be somewhere over here. This is 1.5. And now this is going to be the resultant vector. How you can calculate the magnitude of the resultant vector? This is the hypotenuse. So you just need to do, 2 square plus 1.5 square equals to the resultant velocity square. Taking the square root, you would be having square root of 4 plus 1.5 is 2.25. If you're going to solve it down, you should have 2.5 meters per second. That is how you calculate the velocity. The magnitude of this vector has to be 2.5. And if you want to calculate the angle gonna be tangent theta is equals to opposite over adjacent TOA. Opposite is 2, adjacent is 1.5. So theta comes out to be tangent inverse of 2 divided by 1.5. And you'll eventually get, theta is equals to 53. And the magnitude of velocity is 2.5 meters per second. That is how you were supposed to do this question. Now you've got this question number 11. And in question number 11, the student investigates how the resistance of the length of the nichrome wire, right, changes with temperature. The student takes measurements to determine the resistance of the wire at different temperatures. Draw a diagram for the circuit student should use. Draw a diagram for the circuit the student could use, which circuit diagram it could use. So first of all, you guys must have a battery, so you must have a battery, something like this. Then you have got a circuit, and you have to go with the length of the nichrome wire changes with temperature, and you need to calculate the resistance of the wire at different temperatures, right? To determine resistance of the wire at the different temperatures. The student is investigating how the resistance of a length of nichrome wire changes with the temperature. So what else do we need? We need an ammeter to calculate the current. Then we would need a nichrome wire. This is, let's suppose, be a nichrome wire. And plus the resistance of this nichrome wire can be calculated by using an ohm meter as well. So we have got this ohm meter. And then, yeah, that's it. Plus, we need a voltmeter connected in parallel with the nichrome wire. Got it? Ji? So what would happen? The ohm meter gonna give you resistance, and this current and the voltage would give you an idea about the different temperatures. So by varying the current and the voltages, you can vary the resistances as well, right? That is how the diagram you can use to calculate the effect of resistance upon temperature. Now, in the second part, the wire has a thin electrically insulating coating so that it can be coiled up without causing a short circuit. The student places the coil of water into the water bath so the temperature uh, So we need to describe how the student could determine the temperature of the wire accurately. Okay? How can the student determine the temperature of the wire accurately? So what he gonna do? He can use the measure the temperature of the the water with the help of a thermometer. So what he gonna do? He's just gonna place that wire into the water, and then he can just stir the water to for the uniform spread of the temperature. And once the temperature is spread uniformly, he can just use the thermometer to get himself the final temperature. So first of all, what you're going to do, the first point that he can use a thermometer, right? And with the help of thermometer, he can just dip it in water. Secondly, what he can do, he can just stir the water, right? Stirring the water would help you to uniformly, spread out or elongate the temperature. So stir the liquid or the water, and then thermometer. You should be placing the thermometer near the coil as soon as you're done with it, right? So that is a second alarming. So these are the three steps by which students can measure the temperature quite accurately. Now, in this B part, explain in terms of the particle behavior that why the resistance of the nichrome wire changes as the temperature changes. So first of all, we just need to talk about that why the resistance of the nichrome wire changes as the temperature changes. So what we know as the temperature increases, kinetic energy of particles increases, kinetic energy of the particle increases, thus increasing the frequency, hmm, sorry, frequency of collision of electrons. And as soon as the frequency of collision of electron is increased, drift velocity, collision is going to oppose the actual flow or actual vibration of the electrons. So drift velocity going to decrease. Drift velocity would decrease. So the current, right? The current would decrease. And as soon as the current going to decrease, the resistance of the wire going to increase. So you need to mention these 4 points while talking about this 4-marker question. Now, next, we've got this question number 12. A wire wound resistor consists of a long length of wire wound around an insulating core. A technician finds a wire wound constant and resistor labeled 80 ohms. Calculate the length of the constant and wire using the, used to make the resistor. So we just need to use R is equals to rho L upon A. And now this equation would become L is equals to R A upon rho, right? You have got the resistance. The resistance is 80. You've got the diameter, just convert it into the radius and, calculate the area. It's going to be pi times 0.14 times 10 raised to the power of minus 3 square. So this is 80. 80 times pi r square divided by the resistivity. And the resistivity going to be 4.9 times 10 raised to the power of minus 7. That is how you can easily calculate the resistance. So you've got 80 times pi times r square divided by 4.9 times 10 to the power of minus 7. That is how you'll get the resistance. You'll get the length, right? By just plugging all of these values in the calculator, you would be having the final answer as something like 10 meters, right? Now you've got this question number B. A potential difference of 9.8 volts applied across the resistor and current in the resistor is 0.1212 amperes. Deduce whether the value labeled on the resistor to support these data. Uncertainty in the potential difference is 0.1 volts. Uncertainty in the current is plus minus 0.01. The labeled resistance on the resistor was 80 ohms. So we just need to check that by having resistance from these calculations, would it be in this range or not? So first of all, what you're going to do, you just need to calculate the resistance. And the resistance comes out to be, whenever you're talking about the resistance comes out to be 9.8 divided by 0.12, which is basically 82 ohms, right? If you want to calculate the resistance, the total percentage uncertainty, that gonna be, you can see that, first one of them is 9.8 was the voltage. The uncertainty in the potential difference is zero point 0.1, so zero point 0.1 divided by 9.8 multiplied by 100 plus 0.01 divided by 0.12 multiplied by 100. If you just solve them down and, if you're just gonna add them up, you should have 9.3%. So this resistance is there with a percentage uncertainty of 9.3%, right? Now the 9.3% of 82 going to be something like, for example, if I talk about it, 82 minus 9.3% of 82, that comes out to be 74. So 74 is the lowest estimator of the resistance, but the resistance marked on the resistor is something like 80 ohms. So this is adjustable, right? So that is how we're going to go with this resistance. Is that clear? Now we've got the next question, and that is question number 30. Some students use a plank to make a bridge across the stream. The plank rested on the rock as well as the wall. This is the wall, this is the rock. Assume the plank is uniform. Show that the weight of the plank is about 250 Newton. So if you want to calculate the weight of the plank is 250 Newton, just use W is equals to mg. So you would have the final answer. M is 25 times a G has to be 9.81. So you're just going to times them up and you'll get the final answer. And that comes out to be something like 245 Newtons, right? Now, in the B part of the same question, you need to determine the force exerted by the wall on the plank. Yani you need to determine the force exerted by the wall on the plank. So I'm taking this as a point of pivot, right? So there are two forces acting across the pivot. That is the weight of the plank itself and the upward force on the plank by the wall. So I'm just going to use the principle of moments. If I'm talking about the weight of the plank, it has to be 245. The moment due to the weight of the plank should be 245 times. The total length of the plank was 5 meters. It must be acting at the center of gravity, so you were going to use 2.5. We're going to keep it equal to the upward force exerted by the wall, and that has to be something like F times the distance between the wall and the rock itself is something like 5 minus 1.4, which must be whatever it is. 5 minus 1.4 has to be 3.6. So by just using F from here, 245 times 2.5 divided by 3.6, you'll get the final answer, and that final answer is going to be 174 newtons. So that is how you can get the force exerted by the wall on the plank. In the B part of the same question, a student weighs 550 Newton, states that the plank will tip if she walks from the rock to the other end of the plank. Yani her weight is 550, and she's just telling us that it would tip when she's gonna move from the rock to the wall. So first of all, if you talk about if she's walking from here to here, from here to here, and for example, by walking from here to here, for example, she reached at the wall, something like this, right? Let this point be the pivot, and you can see that if this point is the pivot, the weight, that moment of that girl gonna be 550 times 1.4, 550 times 1.4, and that comes out to be 717 nanometers. Got it? Now, moment due to weight. Moment due to weight is going to be, weight was 245, right? Times, if we consider that thingy, the distance from that pivot should be 2.5. Total, it was negative 1.4. If you just work it out, you will have 270 nanometers. So you can see that 770 is greater than 270. So the student was right. The plank would tip, right? Based upon the conservation of the moments on both the sides. Since the moments, anti-clockwise moments is not equal to the clockwise moments, so the plank, there is a very high probability that the plank would tip, right? So we're done with 13 questions of this paper, 23, which is also a guest paper. This is a part 2 of the video, and I'll be back in the next video, starting from question number 14. So stay tuned. Thank you very much.